Hi friends. In the previous video, I was already explained the block diagram as well as pin diagram of 8251 IC. Nothing but the USART IC. Also call it as a universal, synchronous, asynchronous receiver and transmitter IC, right? So in this video, let us see how 8086 is interfacing with the 8251 IC. Okay, let us see. See here. I will take highlighter. Now let us see topic once. Interfacing 8086 with 8251. Interfacing 8086 with 8251 in IO mapped IO. So in IO mapped IO means the number of address lines should be 8 or 16. If it is direct addressing mode, 8 address lines. If it is indirect addressing mode, we use 16 address lines. And one more is in IO mapped IO, the M by IO bar signal must be low. Like that, we have already a minimum idea, right? Now let us see here. This is the diagram. Okay, based on that, we can understand how 8086 is interfacing with 8251. This is 8251, and all these signals are coming from 8086. Okay, now let us see few points first. Okay, 8251 having 8 data lines D0 to D7. So these 8 data lines are bidirectional, and these 8 data lines are connected to Prasad data bus. Okay, D0 to D7. And 8251 also having reset and clock. These two are connected to reset and clock of the 8086, and reset and clock of 8086 is also connected to external clock generator. Then read bar, write bar, and here we are using A1 address line of 8086 to C by D bar signal. CS bar is activating with the help of set of address lines. Here also CTS bar, clear to send bar, is connected to ground. Okay. Then RXC bar, receiver clock pin, similarly transmitter clock pin, both are connected to same, okay, from pulse generator or timer circuit. TXD transmitting data to external device, RXD receiving data from external serial port device. Okay, like that we have connections. Let us see briefly. Coming to first 8251, in that D0 to D7 address lines are connected to lower address bus of the 8086 microprocessor. Okay, so for example, processor wants to send data to external serial port device. In that case, what happens? Processor sending its 8-bit data to 8251 through data lines D0 to D7. So after receiving the 8-bit data, what happens? 8251 transmitting that particular data to buffer register. Okay, buffer register taking the parallel 8-bit data. Later the data is transmitted to output register. In that output register, what happens? It will convert the parallel data into serial data, and that serial data is transmitted to external serial port device via TXT pin. And the rate at which the TXT pin transmitting the data is decided by TXC bar. Okay, because TXC bar is connected to external timer. With that baud rate, TXT transmitting serial port data to external serial port device. Okay. So in that case, which signal it will activate? Read bar signal. Okay. Similarly, for example, processor wants to receiving the data from external serial port device. In that case, what happens? First, external serial port device sending data to 8251 with the help of RXD pin. Okay, RXD pin receiving the serial port data from the external serial port device. After receiving the serial port data, then a receiver transmitting that particular data to input buffer register. Okay, then input register receiving serial port data, and the data is transmitted to buffer register, where that input serial data is converted into parallel data, and the parallel data is given to data bus D0 to D7, and the D0 to D7 is transmitted to data bus of the processor. Like that, a processor receiving the data from the external serial port device. In that case, it will activate the signal. In that case, it will activate read bar signal for receiving. For sending, it will activate write bar signal. Okay, remember, for sending the 8008, similarly for sending the 8086, its 8-bit data to external serial port device. In that case, it will activate write bar. For receiving data from external serial port device, in that case, it will activate read bar signal. Like that, processor will activate read bar and write bar. Now let us say in which way it will activate read bar and write bar. Here also we are taking M by IO bar signal, that should be low for selecting IO. So for selecting IO bar, it should be low. So 0. 0 means we are selecting IO. Here read bar is activating. Okay, so for that 0. Then A0 is also 0. Then all three inputs of OR gate is 0, output is 0. 0 give it to read bar, then it will activate. So here output is IO read bar we are selecting. IO read bar is activating, nothing but 0 is given to read bar, it will activate. Similarly, for activating write bar, what happens? Write bar must be low. A0 must be low. Similarly, M by O bar must be low. Then output should be low. Low given to write bar, then it will activate. Here, what is the name of output of R gate? IO write bar. Here, name of output of R gate is IO read bar. Like that, read bar and write bar are activating. Here, we are freezed to A0 with value 0. Here, A0 is freezed to 0 value. If you take 8 address lines A0 to A7, and we have two registers are mainly present: data register and control register. So whenever C by D bar is okay, whenever C by D bar is 1, we are selecting control register. Whenever C by D bar is 0, we are selecting data register. Like that, C by D bar selection accordingly, we have control and data. Okay, for that A1 is connected to C by D bar. Whenever A1 is equal to 1, then it is called as a control register. Whenever A1 is 0, it is act like a data register. Here, whenever A1 is 0, we are calling as a data register. A1 equal to 1, we are calling as a control register. Okay, similarly CS bar, in which way we are activating CS bar signals. Here, let us see, CS bar is connected as a output of NAND gate. So here A2 to A7 address lines are connected to NOT gates, and the outputs of NOT gates are connected to NAND gate. For example, A2 to A7 all are zeros. Then because of NOT, all becomes ones. Okay, because of NAND, if all inputs of NAND are ones, then output becomes 0. 0 given to CS bar, then it will activate. So for activating CS bar, A2 to A7 must be all zeros. So here A2 to A7 must be all zeros. Which is varying. A1 is changing. It may be the 0 or 1. 0 for data register selection and 1 for code register selection or control register selections. Here A1 equal to 0 for data register and A1 equal to 1 for control register. Like that, what is the overall address for this particular 8251? So all 8 zeros is 00H. Okay, so A1 is 1, remaining all are zeros is 02H. So 00H is the 8251 data register address. Similarly, 02H is the 8251 control register address. Like that, we get the address lines based on the gates. Okay, and how they are connecting to address lines. So coming to this side, there is a TXD. What is TXD? It is a transmit bit, and with the help of TXD bit only, transmit device transmitting data to external serial port device. RxD is nothing but receiver bit, and with the help of RxD bit only, receiver block receiving the serial data from external serial port device. Here RxC bar and TXC bar both are connected to same timer or clock generator. So it indicates that it is operating like a synchronous mode of operation. Okay, so clear to send is connected to ground. So now this pin, this signal is used to communicate with external modem device. Okay. For that we are using clear to send is activating by connecting ground. Then your modem control is interfacing with the 8251 modem control device. Okay, so like that your 8251 modem control is interfacing to external modem device easily by activating clear to send bar signal. Okay, so here the clock rate, the clock of 8251 should be at least 30 times more than the clock of TXC bar and RxC bar. Okay, so like that we can interface 8086 with 8251, in which mapping IO mapped IO, because of 8 address lines and because of activating IO, it is IO mapped IO. Okay, now I hope you understand the interfacing of 8086 with 8251 in IO mapped IO. If it is memory mapped IO, same M by IO bar is now connected to NOT gate, one change, and the number of address lines should be 20. Okay, if it is IO mapped IO, that would indirect addressing mode. Okay, same diagram, increasing the address lines from A0 to A7 to A0 to A50. Okay, in the same manner we can connect it. Okay, so thank you for watching this video. Okay, if you really like, please kindly share my video to your friends and subscribe my channel. Thank you.